In this lesson, we're going to be talking about finding the length of an arc. Okay, so think about, first of all, what an arc is. We know that a circle is, by definition, the collection of all points equidistant from a given center. In other words, if I give you this point and I say, draw me a point that's 4 inches from that point. Well, you might put it here. But you could also put it here, or you might put it here, or you might put it here. 4 inches. Well, if you did all the points that are 4 inches away, you get a circle. That is what a circle is, equidistant from a center. Okay, well, so if the circle is this solid thing all the way around, an arc is just part of that. So if you imagine this as, let's say, a pizza, okay, and let me do this much of a pizza. We're really talking about just the crust of the pizza, right? This is just the edge around. If I ordered 2 pizzas and I said, I'll share with you and we'll make it fair, I'll eat 90 degrees of this pizza and you eat 90 degrees of that pizza. There, that's fair. Do we get the same amount of pizza? No, there's a problem here, right? So 90-degree arc, like you saw in the video of 5.1, the central angle is 90 degrees. That means this arc is 90 degrees. The problem is not all 90-degree arcs are created equal, right? They're not all the same length. So we have another way of expressing how big an arc is, and it's the actual length. So now imagine that instead of a pizza, these are like tracks. Like if I said go out and run the track, and it's a perfectly circular track, and you run around the whole track, and that would be 1 mile. Well, what if you ran 90 degrees around the track? How far have you run? 1/4 of a mile, right? Okay, well, let's say that's this track. This track is 1 mile all the way around. By the way, what's that 1 mile? If you're talking about this as a circle, and it's 1 mile all the way around, what is that? What's that called if you go all the way around a circle? The distance all the way around? Circumference, right? So the circumference of this one is 1 mile. So 90 degrees of that is 1/4 of a mile. All right. Well, what about this track is 2 miles around? 90 degrees of this track is going to be how much? 1/2 a mile, because it's 1/4 of 2 miles. Well, what's 1/4 of 2? 2/4 or 1/2? Right? So it depends on the size of the circle, how long the arc is. So this lesson is basically finding the length of the arc. Now, there's a difference between the measure of the arc, that's in degrees, and the length of the arc. That's in inches, centimeters, feet, miles, meters, whatever. Okay? So this here, we're finding the actual length. All right, so imagine we have this circle, and the circumference of this circle is 48 meters. That's the circumference, 48 meters all the way around. Okay? What if the measure of the central angle is 180 degrees? Well, that's oops, that's pretty far off. That's like if I draw the diameter, 180 is a semicircle. Again, we said how many degrees is around the whole circle? 360. So if we're doing 180 out of 360, what fractional part is that? 1/2. So the length of that arc, if you started here and ran all the way to here, the length of that arc is 1/2 of the whole circumference, which is 48. What's half of 48? 24. Make sense? All right, let's do the next one. The next one is 90 degrees. If we have 90 degrees out of 360, again, what fractional part is that? 1/4. So the length of the arc from here to here is 1/4 of 48. What's 1/4 of 48? 12. The next one is 45 degrees, which basically cuts that 90 degrees in half, right? If the central angle is 45, that means the arc measure is 45. 45 out of 360 is what fractional part? 1/8. So the length of the arc then is going to be 1/8 of the whole circumference. 1/8 of 48 is 6 meters. What about this one? 120 out of 360. That's like 12 out of 36. What fractional part is that? 1/3. So the length of this arc, 120 degree central angle, the length of this arc is going to be 1/3 of 48, which is 16. Okay, so let's do one that's not one of those. Number 1 here, it tells us that the diameter is 24. Find the length. You're always looking for that word length. Right? The length of arc DC. They want us to leave our final answer in terms of pi. Okay, so we're finding the length of the arc. What I want you to realize every time you have a question like this is that the first thing you have to find is what? The fraction, and then what? If I told you to go out and run the track, and I said, run 1/3 of the way around the track, how far have you run? What do you need to know about that track? How far it is all the way around, right? If you're doing a fractional part, you need to know what the whole is. So anytime you have these problems, the very first thing you have to find is circumference. You have to find the whole thing first before you can take a fractional part of it. That make sense? Okay, so if we're finding the circumference, which is 2 times pi times r, they give us diameter. We need to know r. What is the radius? Now, we could have used the circumference formula that says pi times diameter. Sometimes I forget about that one, right? So we could have just done 24 pi. But either way, we plug in 12 as the radius, 2 times 12 is 24. We get the circumference is 24 pi. Now, DC, arc DC, is how many degrees? 60 degrees, because it matches the central angle. So 60 out of 360 is what fractional part? 1/6. So the length of the arc is 1/6 of the circumference, 24 pi, which is 4 pi. And it says to leave your answer in terms of pi. That means leave pi in your answer. And this is centimeters, because it's the length from C to D. Any questions on that one? Yep. Yeah. Okay, let's look at number 2. The measure of angle AMB. AMB. This angle. How are we going to get that angle? Yeah, why 180? Okay, so if we know that CA is a diameter, that's making this a semicircle, which makes the whole thing 180. So this piece, AMB, is 180 minus that 45 that's there, and we get 135 degrees for AMB. Now, this question says find the measure. See that little M? Measure of arc BC. That's like measure of angle. They both have that little M. Whenever you have that little M there, your answer, excuse me, is in degrees. This is different than finding the length like we did over here, right? With the little M, they just want the degrees. So what is the measure of arc BC? 45. Because, again, it matches the central angle. All right, now they're asking us, find the length of arc BC. Length. Now is when we need to do that fractional part of the circumference. How far is it all the way around? What's the fractional part of that distance? Okay, so if BC is 45 degrees, we're going to do 45 out of 360. Which is what fractional part? 1/8. Good. So the length of BC is 1/8 of 1/8 of what? We need the circumference, right? Okay, so what is the radius of this circle? 20. So we need circumference. Circumference equals 40 pi. That's what goes in here. 1/8 of the whole circumference, which is 40 pi. What is 1/8 of 40? 5. So 5 pi is our length of BC. It says to find it to the nearest tenth, so we have to turn that into a decimal. 5 times pi. $15.7. It said to the 10th, right? 15.7. And that is in meters. Okay, you guys try 3, 4, and 5, and then move on to 6 when you're done. I'm going to walk around and make sure you're on the right track. Notice this little M, this little M, this little M. All of these answers are in degrees. This first one is asking for measures of degrees, angle and arcs. Then number 6 says length. So that's when you're going to do the fractional part of the circumference. Okay, so on this diagram here, the first question says the measure of angle IGJ. So we start at I, we go to G, we end at J. That's this angle right here. Well, you might not see it right away. Sometimes it helps to like turn your paper a little bit or whatever, but I can tell you two tips. If you're stuck on anything with circles, 2 things to remember. First of all, find a diameter, because a diameter creates a semicircle. And if you can figure out something that's 180 degrees, sometimes that helps you find the missing angle. So in this case, we have a diameter at Fi, which makes this whole thing 180. It also makes this whole thing 180. So if this whole thing's 180 and this piece of it's 100, then IGJ has to be 80. So that's this answer here. Now, this is just asking us what is the measure of the arc. This is called the intercepted arc of that angle, right? This is the central angle, but it goes out like this, and it cuts off the circle right here. That arc matches that angle measure. So that's considered 80-degree arc. Now, the measure of arc JFH. If it's an arc, we have to go along the circle. Start at J, go through F, end at H. This is a major arc. It's got 3 letters naming it, right? So JFH is that arc right there. Well, we know from here to here is 100. So what we need is what this part is. So we really need to figure out this angle. So again, if this whole thing is 180, and this piece of it is 72, that makes this 108. So therefore, our arc JFH is 100 plus the 108, so 208. Yeah? Okay, number 6, find the length of arc IH. Length of arc IH. Well, if we know that the measure of arc IH is 72, 72 out of 360 is what fractional part? 1/5. Oops, I don't know what I was drawing there. 1/5. 1/5 of the circumference. Well, they tell us the circumference is 25. What's 1/5 of 25? 5 centimeters. That's the length of IH.